Welcome. Today we're going to briefly go over a ModelOp Center integration with Dataiku, and as well as also with GitHub, and how we treat model factories in an independent manner of our solution, and how we actually can describe models in a consistent manner across vastly different model factories. This includes things such as Dataiku, which we'll be demonstrating today, GitHub, which we'll be demonstrating also, and we also have support for things like Jupyter and RStudio and other major model factories as well. How we do this is we actually have what we refer to as our model catalog. Our model catalog is an abstraction of the assets associated with models from different model factories in such a way that it lets us communicate consistently across those model factories and have a consistent view, yet work with the unique capabilities within the different platforms that we have. So for instance, here you can see a variety of models that have been imported from a Git repository, but we can also see models that have been imported from Dataiku as well. So let's see, how do we actually import a model into the system? Well, we'll start out by quickly doing an import from GitHub. So you can see this is a standard GitHub repository, and we're going to grab the clone URL from that. And we can go ahead and just say, let's import that. And we're going to give it that clone URL, tell it the branch we want, and then just click import. Now what it's doing is it's actually communicating out and locating the repository, cloning that into a local copy, and then pulling together all of the information about the assets that can pull from that particular platform. So now we can see that we've grabbed basically the individual sources that are available, both a Python and a decision table. And then additionally, we were able to grab some attachments that were associated with some test data and a weights file and things there. But you notice GitHub doesn't really have the concept of platform information, so we can't pull that in or that kind of thing. And it doesn't define the schemas automatically. So we would have to put that information in manually. Now, when we integrate with a platform like Dataiku, where we can actually communicate directly to the system, we automatically import all found recipes and items that are there. So we can see here where we have that same format of a model and another ecom lasso model, but this time from Dataiku. Now, Dataiku does provide us robust platform information. So, for instance, we can pull down all of the details from Dataiku. We can see the project that's associated with it. We can see the specific recipe we're communicating with in this case. We can pull down the schema information that you can see here directly from Dataiku, as well as things, as well as we can also get a link right to the project, so we can jump immediately into the Dataiku environment since it's web-based, so that we can work on that particular project and that particular source code and do our work here and do runs and make modifications. As we make modifications within Dataiku and update, they'll automatically be synced into ModelOp Center without any required user intervention. This creates a powerful methodology of doing that. But like, as we mentioned, we have the platform-specific information from Dataiku, but we also can translate into the common view we see with other items. So we can capture all the different, if there's source recipes, we can capture that information into standard source files that we can do. We'll grab that metadata about where we actually pulled it in from, about the recipe and the types and things like that, so that we have that information. Also, we translate the schema that Dataiku provides from their proprietary format into a common Avro format. This has an advantage in that, again, we can communicate about what kind of a data record each model expects, independent of the platform it was developed on. So if we do this within Jupyter, if we do this within RStudio, we're going to have that same industry standard Avro format to know what kind of data and what format of record that this particular model both expects coming in and puts out. So not only do we preserve the Dataiku information about the particular data source, but we additionally translate into this common language we can talk about as well. And we capture attachments if they exist as well. So you can see overall, we can bring those resources from Dataiku into a consistent language. We can talk across all of the different model factories to tie them all together and then run them through our model lifecycle. Also, additionally, we want to point out, not only do we integrate Dataiku as a model catalog where we can pull information about resources, but we also bring it into our framework for being a runtime target. Basically, you can see here that we have the Dataiku engine available, and we can check its status and things like that. And we can also create jobs that we actually launch into the Dataiku environment, where we can capture details about what went on, their logs, and that kind of item. And that will be a consistent view no matter which kind of a runtime you actually choose to utilize to run it on, because we also have our own ModelOp Center runtime, which can run these same batch jobs on that kind of thing. Now, obviously, a Dataiku recipe, since it's heavily tied to the Dataiku platform, has to run on a Dataiku engine on that kind of things. But if it's a generic Python model, it could also be run on our engine as well. So with that, that's our introduction to basically our integration with Dataiku and how we can work across multiple different model factories in a consistent manner to actually provide all of the model lifecycle stuff, which we'll go into in another demonstration, where we can move your model through the business no matter what model factory you choose, and provide you that governance and regulation and consistent view within all of the organization.